Hi, my name is Dylan McElhatton and I am with Halogen Systems Technical Support. Today we are going to be doing reference calibrations. We are going to be doing temperature calibration, pH calibration, and connectivity calibration. The importance of reference calibrations is all of our sensors use our reference measurements to compensate for our chlorine calculation. The more accurate we can be to our references, the more accurate our sensor is going to be. All of these parameters are calibrated by us here in the factory, but if your sensor is a year, 2 years old, this is something that you might want to do annually as well as you start to see if there's any sort of drift or change in measurements over time. The things that you're going to need to complete this is, of course, a sensor and a display. This can also be completed using our MP5 Connect software as well. The first thing that we're going to do is the pH calibration, and we're going to use a calibrated reference pH meter. By calibrated, I mean this should have done a 7 and 10 buffer calibration. We should confirm that we're very confident in this reference measurement. This can also be done with the sensor installed in the process if you have an additional pH meter that's monitoring the same process water. So in this case, I calibrated this morning. This is going to be our reference pH probe. This is just sitting in some pH electrolyte solution, just 3.5 molar KCl. We're going to go ahead and put it into the same water that the sensor is seeing, and we're going to turn it on. We're going to give it a couple minutes to equilibrate to the water solution, and in the meantime I'm going to come over here and walk us through basically what we're going to be doing. So right now we're going to go ahead and do our pH calibration. So maybe over time we're starting to notice that our pH here is a little bit different than our reference pH measurement. This should only be done if it's really difficult to uninstall our sensor or if you just want to make a small minute adjustment to our calibration. For the most part, I recommend that you always do a 7 and 10 buffer calibration because that'll be more accurate to our exact sensor's pH sensitivity. So I'm going to pull our reference meter over here. So if you notice, we have a little bit of a difference in our pH measurements here. Our pH meter here is happy, meaning that it is stabilized and calibrated. We're pretty close on temperature as well. So I'm going to go ahead, and because I want to close this gap, I'm going to do a single point pH calibration. And I'll show you how to do that now. You're going to go to Menu, Calibration, and pH. And this can be done via the long menu or the short menu without the long menu active. We're going to do single point calibration. And we're going to put in our known pH value, which, if you look here, is 8.56. So you're going to hit select. Use the right, left, and up and down arrows to change these numbers to 8.56. And to save the calibration, we'll hit select. You're going to get stabilizing. This could stay on the screen for up to a minute. If the calibration is out of range, you will get a failed here as well as a error 16. But in our case, we got a successful calibration and pH went directly to 8.56. So, as easy as that, that is our pH reference calibration. Next, we're going to do a reference temperature calibration. And again, you're going to want to use a calibrated temperature meter. And to calibrate, you can either use an NIST traceable probe that comes from a factory calibrated, or you can do a calibration using frozen DI water dissolved into DI water, and that'll be an absolute, or close to zero, that you can use to calibrate your meter. So in this case, I have an NIST traceable temperature meter. I'm going to go ahead and drop our probe into our solution. And I'm going to give it a couple minutes to equilibrate here. So once you're confident in your temperature probe measurement, we're getting pretty stable at 19.7 now. And if I look here, our temperature is 21.0, so there's a little bit of a difference there. So I want to level out that difference. Then I'm going to complete a temperature calibration. To do this, you're going to have to activate the long menu, holding select and right arrow for 3 seconds. You'll see the L as confirmation that the long menu is active. and we're going to go to calibration, and we're going to scroll down to temperature, and we're going to put in our temperature that we want to calibrate to. Now remember, if it says unit F here, but you're using a reference of unit C, you need to go down and change this to whatever calibrated reference you are using. In my case, I am using degrees Celsius, and my reference measurement is 19.7. So I'm going to use the up and down and right to left arrows to change this to 19.7. And I'm going to hit select, and then I'm going to scroll down to finish to complete the calibration. And success. And we'll go back to the menu, and we'll see that our temperature has updated to 19.7. And that, as easy as that, to calibrate our temperature. Next up, we're going to calibrate our conductivity. We're going to do the same thing here. We want to use a calibrated conductivity meter reference. This can also be done using a conductivity standard as well, such as 14,000 or 25,000 microsiemen per centimeter. Or you can use a reference meter as well. In this case, we're going to use the reference meter. And we're going to put that into our solution. And we're going to let that equilibrate. So there's two ways to do the conductivity calibration with the long menu. We can go to Menu, Calibration, and Conductivity. And you're going to notice that there's a cond known here. Now you can do this with just whatever water solution that is representative of your process while the sensor is running and you have a calibrated reference meter. Or, like I was saying before, you can do this with an off-the-shelf conductivity standard as well. So, our conductivity value right now is 487. I'm going to take a look at my reference meter, and we are still stabilizing. And our value is now holding pretty good at 401 microsiemen per centimeter. So we're going to go ahead and calibrate to that. We're going to go to Calibration, Conductivity, Cond Known. We're going to use the right and left arrows and down arrows to change this to 401. And hit select to save, and you'll get a success. So revert back to our main measurement window. And you'll notice that our conductivity has updated to 401. The same can be done for ORP calibration as well. I don't have a reference ORP meter here, but if we wanted to complete an ORP calibration, say I know that our ORP of this solution is 422, you can navigate to ORP, hit True ORP, and change that value to 422. Hit select, go down to Send to Board, and that's going to update our ORP offset. You will see that when we go back here, and now ORP is at 422. Now, for any reason, if you weren't confident in these calibrations or you calibrated incorrectly or put the wrong value in, don't worry, we save all of our calibrations to defaults that we completed here in the factory. So if you navigate to Calibration, the Calibration menu, and you go all the way down here to Cal Defaults, this is going to set our sensor back to our factory stored calibrations, and these are all specific to the individual sensor. Go ahead and hit Set to Defaults. Say, are you sure? Yes. And it's going to restart the sensor as well as the display, and it's going to revert all of our calibrations that we've done back to what we did here in the factory. This is a good way to clear errors or if anything else is going on that is causing your sensor to run non-optimally. Go ahead and hit Cal Defaults as one of your first troubleshooting steps. That is reference calibrations for pH, temperature, and conductivity, as well as how to revert our calibrations back to factory stored defaults. Thanks for watching, and if you have any additional questions, please reach out to tech@halogensys.com.